Hello, this is John with Star.make and welcome to another thrift store finds video. I only have one find for you today, and that is a slide rule. And I know what you're saying, slide rule, that's math, right? Yeah, I'm sorry. We're not going to get too far into that. We're not going to get too far into the operation of the slide rule. I just wanted to kind of show it to you and just give you a little bit of information on it and how it's used. If you're really interested in learning more, I'm going to put some links to some videos down in the description that you can go check out and go from there. But the slide rule is a very interesting piece. I have a few in my collection, and over the weekend we went to a tech swap, and that's kind of like a nerdy thrift store, close enough. And this is the best slide rule that I now have in my collection. And let's figure out how it works a little bit. The slide rule was developed in the 17th century, and it uses logarithmic tables to basically operate and to give us a very interesting way to do multiplication and division. Now the slide rule also will do square and cubed roots and also some trigonomic functions. We're only going to talk about the mathematics and the division today, and they're really easy, so I hope you stick with us. And if you have a slide rule of your own, I hope you pull it out and maybe follow along as well, and you might learn something about how to use it. So let's check it out. All right, over here, so the slide rule is made of a couple parts. Obviously, in the center, that's the slide right there of the slide rule. You've got two pieces up here. You've got a piece up top and a piece down below, and that's the body. It's put together on the corners here with these metal bridges. And then you've got this piece here that also slides. It's called the cursor. And now the cursor has a tiny, thin red line called, obviously, the hairline. And that's to help you figure out, once you put it on something down here, you can kind of read that hairline all the way across the slide rule. Now I really do apologize if you're not seeing the numbers or the hashes here. As I put the rule on different areas of different numbers, I'll call them out just in case this video doesn't really show that detail, or maybe the quality you're watching the video is just not as good. You know, we'll work around that. I also apologize for all the ink on my hands. We're working on a 3D video on filament dyeing, and man, the ink that we're using does not want to come off. So future myself, make sure that video tells people to wear gloves. I'll forget that, I know. Okay, so let's take a look at the slide rule. It works on logarithmic functions and a logarithmic table, which is basically, if you take a look down here on the screen, we're starting at 1 and we go to 2, 2 to 3, 3 to 4, all the way up here to 10. So the interesting part is the 1 to 2 is quite wide, where all the other ones get thinner and thinner and thinner. We have two of those. We have one on the bottom of the slide, and that's the C scale. We also have one on the top of the bottom body piece, which is the D scale. And if we line them up together, they line up perfectly. But the interesting part about that is if we kind of offset them, and this works on a logarithmic equation that is log xy is equal to log x plus log y. You know, it's not something you need to worry about. If you're interested, there are plenty better videos that explain it. I'm not going to bore everyone with that, but it is interesting if this is something you find fascinating. So let's say we want to do a basic multiplication on the slide rule. How do we do that? So we're going to do something very basic. We're going to do 2 times 2. Don't contain my excitement, right? Okay. You've got these 2 points on the C scale. You've got a left index and you've got a right index. And this right index is basically your 10. The difference on what you use is depending on what equation you're working with. So let's say we want to do 2 times 2. We're going to put that left index on the 2. Make sure I have that centered. And if we look now, 2 times 2, we've got 2 and 4, 3 and 6, 4 and 8, 5 and 10. And that's all well and good until you want to go to 6, 7, 8, 9, or 10. And then we use the right index. And how we do that is we take the right index, which is the 1 or the 10, bring it all the way down here to 2. We look on the monitor and make sure we're lined up again. And now we can finish that scale. We can finish with the 5 and 10, 6 and 1.2. So here's the interesting part about the scale is it's not giving you your absolute functions. You're basically guessing, and we're going to do another equation after this that you're basically guessing where your decimal points are going, and you're guessing where, you know, any extra zeros are going to lie. So obviously 2 times 6 is not 1.2, but you need to be a little bit on the smart side to know kind of where the number, where your result is going to end up. If we look further up the scale, we've got you know, 2 times 7 is 1.4, and so on. And that's great, but the problem is single-digit multiplication scale is not going to impress your friends and family. Here's how we do something a little more difficult. With this scale, let's pretend we're going to do, let's say 250 times, let's say 70. We're going to take the 1 on the left. We're going to place that on the 2.5. And now, have you seen what the problem is going to be? You eventually realize, okay, we're going to be on the wrong scale for that. But if you look down here, we can see that the 7 is all the way off to the side. We need to go to the other scale. No problem. Bring it down. We're going to put that 1 there right on the 2.5, as close as we can get it. Now, thinking about this, 250 times 70 should put us close to like 20,000 or so. So we know where we should be. Really, with the scale, we're basically doing 2.5 times 7. And then even then, since we're doing we're doing the right index, we're going to get a 1 point something. And that, if we look down there where the 7 is, we're at 1.75. So that tells me that our original 250 times 70 is going to be 17,500. No problem. That's how you do the bigger numbers. You can even do, now obviously 250 by 70 is not that difficult. You can do a lot larger numbers, but let me tell you about the difference between precision and accuracy. Accuracy of this scale is spot on. The only problem is the precision. And while this scale here is really precise, when we get down to this area here, the 9s, look how squeezed together those are. Now we have the ones too, you know, we have tick marks every tenth on that 9, but if you're coming up with an equation that's got a lot of characters on it, a lot of digits on it, it may be really hard to figure out, okay, is it a 90.9 or is it a 91.1? It can be really hard to figure them out. The slide rule with those in those instances are going to get you to the basic general area. If you really need precision, then you would break out the long math or the long division, and then you would work with some smaller numbers and go from there. Let's check out a division and see what we can do on that. Division is pretty much the opposite. Instead of doing your index, putting your index on one of the numbers that you're multiplying, you're going to use the index as your result. So what we're going to do is, let's say 7.5 divided by 6. What we're going to do is we're going to put the 6 and the 7.5 together and see where the index lies. For that, let's see if we can do this. Let's see what scale we need to do. So we're going to put the, and I'm looking at the monitor right now, we're going to put the 6 on the 7.5. Are we doing good there? 6 on the 7.5. Come on. There we go. Now, as you can see, the slide kind of slides a little bit easy. And the interesting part about that is when you're working with the slide, when you're holding it like this, you can put pressure on that, and that's not going anywhere. And typically, wherever you would have put your cursor and your hairline, you'd put that on your result. And this cursor is a little bit loose. I do intend to take this off and tighten up the springs in there. But normally you would be able to put this on your number, move around your scale, and then continue from that. So if I put this on 6 and 7, what did I say? 7.5 and 6. So if I put the 6 on the 7.5. Come down here to the 1, that should be 1 1/4. And looking at the screen, that's where we're at. So we're at, here's the 1, 1.1, 1.2, 1.3, and we're between the 2 and the 3. So perfectly 1.25. But do you see what I'm talking about with the precision? Obviously with the 1 to 2, I mean, you've got you got tick marks for days that you can get really precise. Where you slide up to the 9, then you have issues. So so that's pretty much it. That's all I'm going to really bore you with the slide rule. The slide rule is it was used in the before calculators came out. I mean, this is what people made with, and it's amazing how many innovations came about using just this thing here. Now, of course, you had long math and long division too, but how cool is this? How cool is this if this helps shape the country and shape the world? So if you have any questions about the slide rule, please put them down below. As I said, I'm going to put a couple links down in there as well in the description. If you want to read, if you want to view a little bit more about the slide rule. Do you have your own slide rule? Please follow us at Twitter. We're at star.make. Share your slide rule with us. We'd love to see it. Also, if you like this video, give us a like. If you want to see more and you want to be notified when we come out with new things, subscribe. When you like and subscribe, we know that that this kind of stuff is what you're really interested in, and we'll make sure to do some more. So thanks for joining us, and we look forward to seeing you next time. Goodbye. See, I told you it was the chair.